In the previous video, we defined logarithms and we also took some logarithms and we turned them into their exponential form. Now what we're going to do is we're going to take a look and go the other way in which we take these exponential sorts of equations and convert them into our logarithmic equations. And remember, if you have log base b of x is equal to y, that means the same thing as x equals b to the y. Okay, so that's going to be, again, important that we remember this throughout the remainder of this section as well as the remainder of the semester. So 3 to the fourth is 81. And so we can clearly see that 3 is the base, so that's going to be b. 4 is the exponent, so that's y. All right, and so what we can do is we could say, remember, the phrase logarithm is an exponent. So exponent, which is 4, is a logarithm. So that's log, the base is 3, and then 81 is the number that's basically our independent variable. Okay, so that's it for it. Again, just remember the phrase logarithm is an exponent, and that could probably be really helpful for you. Okay. We have this 1/25th is 5 to the negative 2. So exponent is negative 2. So logarithm is an exponent. The base is 5. And then we have this 1/25th. And so that's what it's going to look like. Okay, so pretty easy. Okay, just remembering that phrase logarithm is an exponent or just looking up here. Okay, this one a little bit sneakier because we have the fifth root of 1024 equals 4. So one thing that we should probably do is first convert this. And we haven't seen this yet, I don't believe, in the course. But if you have if you have a radical that has index of b, what you can do is you can turn that into a rational exponent. Okay, so instead of fifth power or fifth root, you could turn that into the 1/5 power. Okay? Now, again, our exponent is going to be 1/5. Our base b is 1024. And then we have our 4. It's going to be the independent part of this. And so logarithm is an exponent. So 1/5 is our exponent. Our base is 1024. So we're going to have log of 1024. And then we have 4 is the independent variable. All right. So that's just our conversions. They're not too difficult. Now, one thing that we're going to have to do in this course is we're going to have to evaluate logarithmic expressions. And so we have log base 3 of 27. And what we want to do is we convert it into the exponential form and then evaluate. Okay, so this is actually fairly easy if we just go through and set this equal to x. And then what we can do is we can convert it. Okay, so remember, base is 3. So if we convert this, this would be 27 equals 3 to the x. And then we just have to think to ourselves, okay, well, what number can we raise to the 3 to the third to be able to get to 27? Or we could just rewrite 27 as 3 to the third. Right? So this 27 becomes our 3 to the third. And then I think it's pretty obvious that because they both have the same base of 3, we could just say that 3 is equal to x. Okay, so that's our process. We just go through and we have to think if we can write the left-hand side with a base of whatever's on the right-hand side of this instance. Okay? A second example of this, log base 2 of 64. Set that equal to x. 2 is the base, x is the exponent. So this becomes 64 equals 2 to the x. Now we think to ourselves, how can we rewrite 64 with a base of 2? All right, so 64 is going to be 2 to the 6th power. All right, and so an easy way to think that is count your powers of 2. So 2, 4, 8, 16, 32, 64. If you count that on your fingers, that you multiply 6 times. That's equal to 2 to the x. And we can clearly see that this implies that 6 is equal to x. All right, so basically what we're saying is that 6 is going to be the answer for this. A couple more examples. Now, we don't like fractions a lot, but we're going to deal with them. So our base is 2. We're going to set this equal to x. And so this means that if we have our base of 2 and exponent of x, that means 2 to the x equals 1/8. All right, now, if we ever have a fraction, okay, like 1/8 or 1/16 or whatever it might be, we're going to introduce a negative exponent. And so what we're going to do is we're going to rewrite this as 2 to the x equals 8 to the minus 1. All right, so remember, a negative exponent can flip a fraction around. We know that 8 is the same thing as 2 to the third. All right, so what we can do technically is we can write this as 2 equals 8, or I'm sorry, 2 equals 2 to the third to the minus 1. Or another way to write that is 2 to the x equals 2 to the minus 3. And we can clearly see that x is going to be minus 3. Okay, so usually we have a fraction like a 1/8 or a 1/27 or something of that nature, the logarithm is going to evaluate to a negative number. We have log base 7 is 1 of 1/49. Set that equal to x. 7 is the base, right? So we have 7. Logarithm is an exponent, so x is the exponent. And then we have 1/49. Just like we did in the previous problem, we're going to take and implement a negative exponent. So we have 7 to the x equals 49 to the negative 1. We know that 49 equals 7 squared. So we can write this as 7 to the x equals 7 squared to the minus 1. And then we can now multiply by using our exponent rules. So 7 to the x equals 7 to the minus 2. And then clearly, we can see that x is going to be equal to negative 2. All right. So logarithms aren't all that bad. Okay. It's just making sure that we remember some basic algebra rules with negative exponents, etc., as we're going through. All right. So in our next videos, we're going to take a look at a few more that are a little bit tougher. And then we're eventually going to get to the point where we can graph our logarithmic functions.